All right, in this video, we are going to apply what we learned about rewriting radical expressions using rational exponents. So we're going to particularly focus on simplifying radical expressions. So make sure you put today's date in the top corner of your paper, and then let's take a look at simplifying expressions. All right, the first type of problems we're going to see are when we're evaluating using rational exponents. So we're going to evaluate the following. Let's say I asked you to evaluate 81 to the 1/2 power. So there's actually two ways we can go about doing this problem. You can rewrite it using radical notation. So I can rewrite this. Remember, the radical is what it's in the denominator. So this is the square root of 81 to the first power. So the square root of 81 is just 9. So using radicals and exponential notation, we can kind of figure out what our answer is going to be. So we have the exponents as the rational number. We turn that into a radical, and then you can square root. You can also just use your calculator. And if I want to do 81 to the 1/2 power, I'm able to do that as well. So your calculator will do it right away for you when you're given these rational exponents. 81 to the 1/2 power is 9 because it's the square root of 81. Let's try some other examples. Let's say I gave you 8 to the 1/3 power. The same idea, I could rewrite this as the cubed root of 8. And on the calculator, the cubed root, remember, you just hit math and then number 4. So the cube root of 8 is just 2. If we wanted to use the calculator without having to convert it, you could just do 8 to the 1/3 power. And that also would give you the same answer because these are the same things. They're equivalent expressions. Let's take a look at one where the numerator is different. So let's say I had 36 to the 3/2 power. So remember, the denominator tells you what your root is, so it's the square root of 36. And then we're raising it to the 3rd power. So the square root of 36 is 6. And then you have to raise that to the 3rd power. 6 to the 3rd power is 216. All right, so we can just do that directly on your calculator. And we're going to take 36 to the 3/2 power. And you get that same answer. So you can rewrite it using rational exponents to convert it to radical notation, or you can use your calculator with these problems. So it's really important that you have those steps down of rewriting it in rational or in using rational exponents. The other types of problems you're going to see are ones that involve letters. So these just had numbers. So now we're going to simplify these expressions, and we're going to use the converting steps that we did in the previous problems. So this is just simplify the following. And my first one will be the square root of 25 x to the 4th. So I want to rewrite this whole thing using rational exponents because it'll help me when I'm simplifying my x to the fourth. So remember, to rewrite in rational numbers with rational exponents, you have to use a fraction. So I'm going to separate this out and just do the 25 by itself. The exponent on 25 is 1, so I can rewrite this as 25 to the 1/2, because remember, my denominator when I do rational exponents is whatever the root is of the square root. In this case, it's a square root, so it's 2. And then for the x, it's x to the 4 over 2. So I just rewrote this using rational exponents. And now I can simplify each of these pieces, because 25 to the 1/2, we just worked on those problems up front on the top. If I type that in, 25 to the 1/2, that's just 5, because it's the square root of 25. And then this I can simplify because I can divide those fractions. 4 over 2 is just 2, because when you can divide, 4 divided by 2, you get 2. So the square root of 25x to the 4th is 5x squared. Let's try another example. We'll have negative the square root of 100 m to the 12th n to the 20th. So I'm going to rewrite this with rational exponent. So it's negative 100 to the 1/2 m to the 12 halves and n to the 20 halves. So on my calculator, if I do negative 100 to the 1/2, I'm going to get negative 10, because it's just the square root of 100 with a negative sign in front. So it's negative 10. Simplify that. 12 divided by 2 is 6, and 20 divided by 2 is 10. So the simplified version of this radical expression turns into this. All right, let's look at some other examples. Let's say what happens when, so we'll do the square root of 49, x to the 7th, y to the 4th, and z squared. So what's going to happen when you have numerators that you can't divide by the denominators? So I'm going to rewrite these with rational exponents. So it's 49 to the 1/2, x to the 7 halves, y to the 4 halves, and z to the 2 over 2. So rewriting that using rational exponents, I just used my denominator as 2 because it's a square root symbol, and then I did whatever the numerator was for each thing, or the exponent was for each thing. That's my numerator. So the square root of 49, or 49 to the 1/2, is just 7. X to the 7 halves, I can't simplify that. Because 7 divided by 2 is a number with a decimal, so it doesn't give me a nice whole number. So I'm just going to leave it as a fraction. 4 divided by 2 is 2, and 2 divided by 2 is 1. So my simplified version here is 7x to the 7 halves, y squared, z. And that's simplifying my problem using radical exponents. Simplifying with rational exponents. Let's take a look at an example that's not a square root, and we'll do a cube root. So this will be the cube root of 125 x to the 15th, y to the 12th. So I rewrite each term with rational exponents. So 125 to the 1/3, x to the 15 over 3, and y to the 12 over 3. Because this time my denominator is 3, because the root on that is a cube root. So 125 to the 1/3, if you use your calculator, is 5, because it's just the cube root of 125 is 5. 15 divided by 3 is 5, and 12 divided by 3 is 4. So my simplified answer there is 5x to the 5th, y to the 4th. All right, for the last problem, sometimes you're going to have problems where you can actually simplify your rational exponent. So let's take a look at an example. Let's say I had the 20th root of x to the 15th. So if I was going to rewrite this, I would rewrite this as x to the 15 over 20. But remember, this fraction you can simplify, because 15 divided by 20 can be simplified. So on your calculators, if you aren't able to remember how to simplify, you just divide 15 by 20. Hit enter, and then math fraction. And it's going to simplify that into a fraction that we'll be able to use. So 15 over 20 simplifies to 0.75, which is 3/4. So I can rewrite that fraction as x to the 3/4. And that's simplifying radicals using rational exponents. That's why we spent some time learning how to do rational exponents. Okay, that's it for this video. You can try some practice problems with these ones.